Hello and welcome to SudoKanard. It's been a long time since I did a test solve video on the channel, and I'm pleased to find that my friend Glum Hippo has set a new puzzle with a somewhat classical mix between two variants, Thermo Sudoku and Killer Sudoku. So Killer means that the sum of all digits is this number, and Thermo means that on each thermometer the digits must increase starting from the bulb. And then there's a subtitle which is not exactly helpful cages. And I can see why they're not exactly helpful, because 31, 32, and all of these sums have a lot of decompositions. Well, actually, 33 has only two decompositions, which are 98763 and 98754. So not that many decompositions, and you can see that there has to be a 7 in one of those cells. And 32 has three decompositions, which are 98762, 98753, and 98654. So we know that 9 and 8 are in those cells, but that's not saying much. Oh, actually, this 6 is helpful, meaning that the decomposition is this one, and now those digits must be 1, 2, and 4, and because of the thermometer, this is 1 or 2, 2 or 4, and the third digit here. But that's not saying much about those decompositions. I like the fact that there are all the cages are pentominoes. I love pentominoes. This 32 cage does not include a 4, so it must contain 9, 8, and 7. There has to be a 1 in one of those cells, together with either 6 and 2 or 5 and 3. Lots of 32 cages. I could almost bet that Glum Hippo tried to have all of them be equal to 32, but he didn't succeed for some reason. Or perhaps he didn't try at all. Well, what else can be said? Not exactly helpful, I'm afraid. Is it about where ones go? Oh, this. Oh, yes, this is actually yes. 31 plus 7 is 38, so these three digits must add up to 7, so they must also be 1, 2, and 4. There has to be 1 and 2 there. They can't go into a 33 cage. 1 has to go, it can't go here, but it can still go in one of those cells. And this is interesting. Oh no, 1 here forbids 1 on those, so 1 has to go into one of those cells, and now 1 must be here, because 1 here, 1 here, 1 has to go there, and because of the thermo, it has to go here. So this is not a 1, and 1 must go into one of those two cells. And something interesting is that this is at least 2, 3, 4, but this can't be a 4, so this is at least 5, and this is at least 6. And those 4 digits have a sum of 13 with a 1 and at least a 6. So this, and it can't be a 7th, so it must be 6. That's the maximal value. And now the remaining digits must be 1, 2, and 4 again. So this is 2 or 4. 1, 2, or 4. There seems to be a theme with 1s, 2s, and 4s. And then there has to be a 1 in one of those cells, but it can't go here. It can still be any of those. "13 here again. Is there some similar logic? This is at least 2, 3, 4. But I don't see any constraint similar as what I had here with the 4s. Something more interesting is that this digit is... both digits are smaller than 6, so there must be 3 and 5. And now this must be 4. And now 8 or 9 here, 7, 8 or 9. That's it. And what I mentioned earlier is that we need either 6 and 2 or 5 and 3. And 6 and 5 can't go here, so the missing digit, the big digit, must be here, and those must be 1 and 2 or 1 and 3. To make this a 13 cage. So the not exactly helpful cages must mean that the helpful cages are those with the missing digits in some way. We already have 4 small digits on this row. Those must be somewhat small. This can't be a 1, it's a minimum of 2. And then if this is a 2, then we have 1, 4. So that's a minimum of 6. No, 6 is not available. So if this is a 2, then this is a 7. And this is 8 or 9. And it can't work. Because if this is a 2, then all the remaining digits in the cage must be 6, 7, 8, and 9. Anyway, we know that those digits can't be 2, 6, or 7, so this can't be this decomposition. So 2 can't be in here. 2 must be in those cells. And it can't be on the thermo because it would put a 1 here, which is not allowed. And something more is that one of those must be 1 or 2 paired with this one, so the other 1 or 2 must be here. And it's actually the same digit as this and this. So the second digit must be here. So we know the decomposition here is one of those, and the 6 or 7 must be here. And because of this digit, only one 8 or 9 must be here, the other one must be here. So now here we have 6 or 7 and 8 or 9. So the digit between them must be 7 or 8. But the only way we can do this is by having 7 out of the cage. That's the only digits that can be out of the cage. So that's a 7, that's a 6. We have a 7 here. And this is 8 or 9. That's really, really beautiful logic. And this 7, those 4 digits must have a sum of 13. So we know that these digits are 1, 2, and 3. And 3 is not here. 3 must go here on this row. And the Thermo is now with this 2, this 1. That's a 4. That's a 2. That's a 1. And there's a 1 here. There must be a 4 here, a 5, and 8 or 9. So this is 4, 5, 8, 5, 8, 9, and any of those digits here. No Thermo here, so we know nothing about those digits. But that's some progress. Where should I look now? What about this 32 cage? This 4, 5, 6 is interesting. Let's have a look. 4, 5, 6 are not here. So we know that this is not this decomposition. So there has to be a 7 somewhere on this shape. One of those decompositions, and it must include a 5 or a 6, and this digit is on one of those ends. It must include a 2 or a 3. Two can't be here, 3 can't be there. Well, that's not saying much. This one too is interesting because those 4 digits add up to 12, so there must be 1 and 2, and they must be here. So this is not a 1, this is a 1. And now this is either 4, 5 or 3, 6. Not helpful. A 13 again here. 2 must be here or there. Can it be here? No, it can't. Let's imagine 2 is here. Then those digits here must be 6, 7, 8, and 9. But then this digit must be sandwiched between 2 digits that are 3, 4, and 5, and this doesn't work. So these 2 must be here, making this a 1, this a 4, and this a 2. Now we get a 2 in one of those 2 cells. And what about this? We know that this 32 is one of those, and the remaining digits must be either 7, 3. Oh no, 3 is not here, so 3 has to go in this cage. So this is the cage, and those must be 4 and 6, and because of this 4, we have 4 here, 6 there. So this must be 3 or 5. By Sudoku we get a 4 here, and only 3 can go along this thermometer. And because of those 3's, we get a 3 in one of those. It can't be here because it's not big enough for this end of the thermo. And the decomposition of this is this one. So we now know that 5 is in the cage, so this is a 3 together with 1 and 2. This is a 2. And the last digit here is a 6. Another question is, was this end of the thermo really necessary? I'm not sure I used it at any point, but I don't quite remember either, so I wouldn't be, well, I wouldn't make a point of it. So we still don't know whether this is 3, 3, 6 or 5, 4. It will be disambiguated by this. Well, it may be disambiguated by this, but the interesting fact is that this 3 gives a 3 in one of those two sets, so 3 is not here. So there must be 5 and 4, and this is a 3. Five must be here. These digits are 7, 8, or 9. This is 7, 8, or 9 as well. This is 5, 8, or 9, but I can't do much with those digits. Here, any one of them is suitable. So I think it's time to have a look at this 30 cage, which is much less restricted than 33 and even 32. There has to be at least 5 decompositions. So what about the 15? The leftovers here? What about them? So 15 with 4 digits. That is really brute force. So how do we get this? 1, 4 wouldn't work. That's 6 possibilities. So 6 possibilities for those 4 digits, and the complement each complement will be a possibility for the 30 cage. Oh, that's not so nice. But how do we make this possible with this? Wow. Well, one can't be here, so one has to be here or there. So we can rule out this one. But what? I need to have a somewhat big digit in one of those cells. Well, can I do something about those cells? This is 7, 8, or 9. No. Oh, there must be a 3 somewhere. Now, what do I make of all of this? There's no 2 in those cells, but there could still be a 2 here, not here, not big enough for the thermometer, but a 2 could go here. If 2 goes there, then this 13 must be one of this 15 must be with those digits. I don't see how it can be resolved. Well, let's do some innocuous pencil marking. I don't think this is really helpful, but I need to do something like this. 5 is in one of those cells, so there's no 5 here. This is also 7, 8, or 9. 3 and 5 are both in those cells. Oh. This part is really confusing. Is there some brute force to do on the thermometer here? Well, this cell, this digit could be huge. It could be a 9. This could be an 8. And let's say 3 and a 1. This couldn't be a 2, but that's already been mentioned. But this could be a 2. If it's not, then no, so this would, then 2 would have to be here or there, making this a 3, this a 2. But then what? 1, 2, still 3 possibilities for this 15. What am I missing? Did I miss something down there? Did I miss something with the former thermometers? No. No, they all work fine. Oh. Is this something about sevens? I know there's a 7 here, so none of those digits is 7. 7 is not here either. So 7 has to go in one of those 4 cells. Let's see something. Something is useful in reasoning with sevens. What about putting a 7 here? It would make this an 8, this a 9. Let's have a look. 7 here. Because of the thermometer, then that's an 8, that's a 9. Making this an 8, this a 9. This a 9. And then that would be a 7. And it doesn't seem to work. Then I would have an 8 here, and together with this 8, this would be an 8. 9 could only go there in this cage. 3 and 6. And 5 here, 6 there. 8 here. 5 there, 8 here. Well, all of this seems to work very well. Okay, let's keep this somewhere. This 7 theory does work very well. Would there be any issue with a 7 here? Then we would have an 8-9 pair. So 7 here would make none of those a 7. But then what? It would rule out those. But that doesn't seem to bring anything new to the table. So it doesn't seem to be anything about the 7 after all. 7 here. We'll make this a 1. This a 2, this a 1, this a 2, this a 1. And now to complete these 15 leftovers, we would need 2, 5 or 3, 4 here. 2, 5 or 3, 4. I can't see what to do with it. I can't even seem to remove this 7. Oh, it looks like someone else has solved the puzzle, but hasn't written any public feedback. Okay. So I need to find something else. 7 doesn't seem to be the place to look. Oh, 6. This is what I've been missing. 6 is not in the 30 cage, so 6 has to be in the outer digits. That's it. That is the only suitable decomposition. So 7 is not here. 7 is in the cage. So that's 1, 3, 5, 6. 6 is in one of those. So 1, 3, 5. 3, 5, 6. So now 7 is in here. So 2 is in the cage, and 2 is not here, and 2 is not here, so 2 is here. That's a 1, that's a 2, that's a 1, that's a 2, a 3 here, a 2 there. The remaining digits here. Oh, that's not a 4. There has to be a 4 here. So this is a 5. And that's a 4. The remaining 4 digits must be 4, 7, 8, 9. Oh, so this is not 4, this is not 7, and it can't be 9 because this has to be bigger. So that's an 8, that's a 9. Okay. Now this is an 8. That's a 9. Okay, so we get the 9 here. This is actually a 7. Five or 8 here. 7 is in one of those sets, so this is 5, 8, or 9. Well, I still need 5, 9, and 4. This is 4 or 5, and actually I get a 9 down there. 5 or 9, 4 or 9 here. This can only be a 7 now. That's 4 or 9. And now the n should be near. I still need 8 and 3 on this row. So 9 is here, 3 or 8. No 9 here, of course. Oh, this 8, so that's a 3. And this is an 8. 3 and 6 to complete this. This is a 5. That's a 1. That's a 3. That's a 6. These must be 5 and 7. This one has to be 5, actually, together with the 6 down there. So I get this 8, this 5, this 8. And I forgot about this thermometer. This can't be an 8. This one is an 8. And I get this 5. That's a 9, sorry. This is a 9 as well. That's a 9. That's a 7. That's a 9. And for the remaining steps, this is a 4. That's a 9. That's a 5. That's a 4. 7 or 8 here. And how do I disambiguate the remaining digits? What is this all about? Oh, something's wrong here. Oh. I forgot to put a 3 in here. So, okay, at this point, there's no 9 here, that's a 7, that's a 9. This is a 3. That's a 4, that's a 5. That's a 4, that's a 9. I get an 8 here, 7, 5, 8, 5, 7. That's a 9, that's an 8, and that's a 7. Oh, okay, that's it. So I spent an awful long time not noticing that this 6 and this 6 made the decomposition here unique. That's 1, 3, 5, 6. That's what took me an infinitely long time compared with the rest of the soul. So that was a very well put puzzle, and the not exactly helpful cages proved in the end to be sufficiently helpful, working in partnership with the thermometers. Now, there's this question about this end of this thermo. Did I use it or not? Well, if you watch the show, you can answer this question. Thanks for watching this video and for watching, not washing this video, and see you soon on SudoKanard.